Chapter 5, Problem 37. A car is traveling at 50 miles an hour on a horizontal highway. There are two parts to this problem. First being A, if the coefficient of static friction between road and tires on a rainy day is 0.100, what is the minimum distance in which the car will stop? And part 2, which is B, what is the stopping distance when the surface is dry and mu of s is equal to 0.600. What we are given in the problem is 50 miles an hour, which is the same for both parts. And for part A, the coefficient of static friction between road and tires on a rainy day is 0.1. And the coefficient of static friction in part B is 0.600. For both equations, we are trying to find the stopping distance, which is x of f. The sum of vertical forces is equal to mass multiplied by vertical acceleration, which is gravity in this case. And we see that the normal force going upwards is equal to mg, which is the force going downwards. We see here that static force is less than or equal to the coefficient of static friction multiplied by the normal force, which is equal to the coefficient of static friction multiplied by mg. Sum of the forces in the horizontal direction is equal to the mass of the car multiplied by the slowing down of the car, which would be acceleration of the car, and it's negative because it's slowing down. We solve for the maximum acceleration, which is A equals the negative static coefficient of friction multiplied by gravity. So the initial and final conditions are the distance initially traveled, which is 0, the initial velocity, which is 50 miles an hour, which is equal to 22.4 meters per second when converted, the final velocity, which is 0 because the car has to stop. We use our standard equation, which is the final velocity squared equals to the initial velocity squared plus 2 multiplied by the acceleration multiplied by delta x, which in this case would be the final distance subtracted by the initial distance. So from the equation we plug in the final velocity, which is 0, and then we find out that it's just 0 equals to the initial velocity squared plus 2 times the acceleration, and because the initial distance is 0, it's just multiplied by the final distance. So we subtract on both sides the initial velocity squared, and we plug in the value for A that we initially got, which would be A equals the negative static coefficient of friction multiplied by gravity. So we would get the equation negative initial velocity squared equals to negative 2 multiplied by the static coefficient of friction times gravity times the final distance traveled. So part A, we divide both sides by negative 2 multiplied by the static coefficient of friction multiplied by gravity, and we get for the final distance traveled initial velocity squared over 2 multiplied by the static coefficient of friction multiplied by gravity, so we get 22.4 meters per second squared over 2 times 0.1 times 9.80 meters over second squared, which would equal to 256 meters. Then for part B, we do the exact same thing, except we replace 0.100 with 0.600, and you get 42.7 meters.